Hey everyone, today we're going to be talking about modeling using variation. The first kind of variation we're going to talk about today is something called direct variation. Consider a situation that is described by an equation in the form y is equal to some constant k times x, where this k is not equal to 0. So, we say that y varies directly as x, or y is directly proportional to x. The number k is called the constant of variation, or the constant of proportionality. So this is an equation that relates y and x together by some constant k. So we want to be talking about how to solve these variational problems. Step 1. Write an equation that models the given statement. Step 2. Substitute the given pair of values into the equation in step 1, and then find the value of k, the constant variation. And then we sub back in that value of k into the equation in step 1. In step 4, use the equation for step 3 to answer the problem's question. Now, I know this might seem a little confusing right now, and so the best thing we can probably do is just to dive right into an example so we can see how this works in action. Consider the problem. The number of gallons of water W is used when taking a shower varies directly as the time T in minutes in the shower. So W varies directly as time T. A shower lasting 5 minutes uses 30 gallons of water. How much water is used in a shower lasting 11 minutes? So, step 1. We need to write an equation that models the statement. And by looking at it, we can see that it's W is equal to KT, where W is the gallons of water and T is the time in minutes. And then we have our variational constant K. Now, step 2, we need to go find K. We were given that 30 gallons of water is used in 5 minutes. So by plugging in those values, we get 30 is equal to k times 5. We divide both sides by 5, and we conclude that our constant k is equal to 6. Cool. So now we have our equation in step 1, which is W is equal to k times t, but now we have an actual k. We have a value that we can sub in for k. So let's substitute that value into the equation. So substitute 6 in for k. Now we have the equation W is equal to 6t. So this means that the number of gallons of water used in the shower per minute is proportionate by 6. So now we need to answer the problem's question. Now we have an equation in hand. Now we can go about answering the actual question. So we want to know how much water is used after 11 minutes. So when t is equal to 11. So we take our equation W is equal to 6t, and we sub in 11 for t, and we conclude that W is equal to 66. That means a shower lasting 11 minutes will use 66 gallons of water. Wow, that's a lot of water for an 11-minute shower. So, how about direct variation with powers? We say that y varies directly as the nth power of x if there exists some non-zero constant k such that y is equal to kx to the n. So this is a very similar problem to the one we just discussed, except this time we have x being raised to some power n. We also say that y is directly proportional to the nth power of x. Now, let's look at another example. The weight of a great white shark varies directly as the cube of its length. A great white shark caught off Catalina Island, California, was 15 feet long and weighed 2,025 pounds. We want to use this information to determine the weight of the 25-foot-long shark in the novel Jaws. So step 1, we need to equate the two variables together. So we come up with the equation W is equal to KL cubed, where W is the weight, L is our length, and K is our variation constant. Now, we reread that first sentence, It says the weight of a great shark varies directly as the cube of its length. So that's why we have this third power here. We're raising L to the third power. So, step 2. Let's use that example that was given, that a great white shark that was 15 feet long weighed 2,025 pounds. Let's use that information to go solve for the value K. So, start with the equation. Sub in 2,025 for W, 15 for L. Divide both sides by 15 cubed. And then we get K is equal to 20,025 divided by 3,375, or about 0.6. So, by using the equation we have in hand and the example the problem gives us, we have determined that our constant K is equal to 0.6. Now that we have this in hand, we can go sub it back into that original equation, and then we get an equation of the form W is equal to 0.6 times L cubed. Now we have our equation. Now we can start taking in the lengths of sharks and figuring out their weight. So, now we need to answer the problem's question. We want to figure out the weight of a 25-foot long shark. So, we sub in 25 for L, and we get the weight is equal to 0.6 times 25 cubed, or the weight is equal to 9375. So the weight of the 25-foot long shark was 9,300 pounds, 9,375 pounds. Appears to be a little typo right there. But so we have concluded that the weight of a 25-foot-pound shark is over 9,000 pounds. That's over 4 tons. That's a pretty massive shark. Now, we've spent this entire time talking about direct variation. Now let's talk about inverse variation. Consider an equation or situation described by an equation in the form y is equal to k over x, where k is not equal to 0. We say that y varies inversely to x, or y is inversely proportional to x. The number k is called the constant of variation. Now let's solve inverse variation problems using the techniques we've been talking about all day. Consider the problem. The length of a violin string varies inversely as the frequency of vibrations. A violin string 8 inches long vibrates at a frequency of 640 cycles per second. We have been tasked with finding the frequency of a 10-inch string. Step 1, we need to write our equation. I is equal to k over f. Okay? All right. Now we have our equation in hand. And we have an example in here. We have this length of this string, and we have the number of vibrations. So we can use this to go calculate our value for k. Solution. Use the given values to solve for k. I is equal to k over f. I is equal to 8 is equal to k over 640. Multiply both sides by 640. And we conclude that k equals 5,120. Now, let's sub that back into our original equation. So we have I is equal to k over f, but we just solved for k. So I is now equal to 5,120 divided by f. Now we can actually go about and actually solve the problem's question. So we have our equation. We sub in for what it's asking, or the length of the string being 10, and we have asked to solve for f. So move f over to the left-hand side. We get 10f is equal to 5,120. Now we divide through by 10, and we get the frequency is equal to 512. In short, a violin string 10 inches long vibrates at 512 cycles per second. Now let's talk about a combined variation problems. In combined variation, direct variation and inverse variation occur at the same time in a problem. So let's see what this kind of looks like. Consider this problem. The number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems, or is the number of problems, and inversely as the number of people working to solve the problems. This makes sense. The more problems you have, the longer it takes, But the more people you have, cuts the time proportionally. So this is how we have a combined variation problem. We know it takes 4 people 32 minutes to solve 16 problems. So we want to know, how many minutes will it take 8 people to solve 24 problems? Step 1. We need to write our equation. We know that the number of minutes is equal to some constant k times the number of problems in the homework set divided by the number of people working on it. So, first up, now we need to find a value of k. We were given an example that we can use to solve our value k, just like we've been doing. So, we sub in for m, we sub in for n, and we sub in for p, and then we get this. 32 is equal to 16k over 4. So 32 is equal to 4k, so k is equal to 8. Now we have our variation constant, and we can go sub this back in to our original equation. And now we have the equation m is equal to 8n over p. Now we're locked and loaded. Now we're ready to go. And now we can go solve these problems that we have been tasked with solving. So we need to sub in for our variables. We had 24 questions and 8 people, and we were asked to figure out how long it takes in minutes. So we plug it in, and we determine that the number of minutes is equal to 24. So it will take 8 people 24 minutes to solve 24 problems. Now how about joint variation? Joint variation is a variation in which a variable varies directly as the product of 2 or more variables. Thus the equation y is equal to kxz is read as y varies jointly as x and z. Now, let's solve a problem of this form. Consider this. The volume of a cone V varies jointly as its height h and the square of its radius r. A cone with a radius measuring 6 feet and a height measuring 10 feet has a volume of 120 pi cubic feet. Find the volume of a cone having a radius of 12 feet and a height of 2 feet. Step 1, we need an equation. So, write an equation from the given statement. V is equal to khr squared, where k is our variation constant, h is our height, r is our radius. Step 2, use that example it gave us to solve for the value k. We have v is equal to khr squared. Sub in for the volume of 120 pi, sub in 10 for the height, 6 for the radius, and then we get 120 pi is equal to 360 times k, divide over, and we get k is equal to pi over 3. So our constant of variation is equal to pi over 3. Now let's take this and stub it back into the original equation. And now we have v is equal to pi over 3 hr squared. So our volume is equal to pi over 3 hr squared. Now we can answer the problem's question. V is equal to pi thirds times the height 2 times the radius of 12. So the volume of the cone is 96 pi cubic feet. That's a really big cone. All right, that's all I have on solving these variation problems.